In this video, we are going to discuss finding the average rate of change of a function. But before we do that, and here is the definition of what the average rate of change of a function is. But before we do that, we're actually going to just do a quick review of what slope is, because to a certain extent, the average rate of change of a function is very much related to the concept of slope. And we'll explain how that is true in just a moment. So let's do this problem and let's find our slope. So quick reminder, to find the slope of a line that contains 2 points, we use a formula. M equals y2 minus y1 divided by x2 minus x1. And what I like to do is I like to label my points, and I'll label them like so. I'll say the first x value, that's x1, and then this one will be the first y value, which will be x2. Which will be y1 as well. And then the other point will be the second x value and the second y value. And the most important thing is just make sure it's x comma y, and make sure that your 1's are together and your 2's are together when you label your points. I'm going to plug in these numbers. And so this is going to be y2 is -3 minus, I'm going to do this below it actually. So this is going to be -3 minus 2. And then on the bottom it's going to be 5 minus, and then notice that my x1 is negative. The number one error people make when doing slope is if the second number after the minus sign is negative, you must make sure that you make it a double negative. The number one error people make is they forget to do that. Now, a double negative is really the same as adding. So 5 minus -1 is the same as 5 plus 1. And now we can just subtract on the top and add on the bottom, and we will get -5 over 6. And that is our slope. All right. So a little refresher of what slope is. And let's go back to this formula and let's just look. What is the average change of a function over an interval I? And look at our average rate of change formula. FB minus FA is very similar to y2 minus y1 if you think about it, right? If we have two x values a and b, then f of b will be your y value for that x value, and f of a will be your y value for the x equals a. And then b minus a is very similar to x2 minus x1. All right, so let's look at this function. And let's find the average rate of change over this interval from -1 to 3. All right, we're going to start by writing down the formula, which is the average rate of change is equal to f of b minus f of a divided by b minus a. And here, my interval, I'm just trying to figure out what is the average rate of change. You always need an interval. So in between what two x values? And my two x values are -1 and 3. And this is actually your a, and this is your b. So first thing you need to do is figure out what f of a and f of b is. So let's start with f. I'm going to write down what f of x is. And f of a is going to be f of -1. So this is going to be negative 1 squared minus 3 times negative 1. And that's going to be 1 plus 3, which is 4. So that's going to be my f of a. Let's figure out what my f of b is going to be. F of b is going to be f of 3, which is 3 squared minus 3 times 3, which is 9 minus 9, which is 0. So again, b minus a, I'm actually going to start at the bottom. That's 3 minus negative 1. And again, here we have that double negative, right? Because a comes after that minus stays in the formula. And when I plug in for a, I plug in negative 1, I get a double negative. And this is going to be f of 3 minus f of negative 1. And I'm just going to plug it in like this just to make it a little bit more clear. And I'm going to plug in my numbers. And so f of 3 we already decided is 0. F of negative 1 is 4. And at the bottom, this is 3 minus negative 1. That's 3 plus 1. So this ends up being negative 4 divided by 4, which simplifies to negative 1. And we are done. So on average, in between negative 1 and 3, my x values, my y value is changing on average by negative 1 every time the x value goes up by 1. That's kind of what average rate of change means. I think to really understand what average rate of change means, let's graph this. So it's x squared minus 3x, x squared minus 3x. Let's go to Desmos. So here's our graph. And we're trying to go in between negative 1 and 3. I'm just going to write down these x values so we can kind of see where they are. So there's my point at x equals negative 1, and then we have x equals 3 right here. Okay. So here are my 2 points. And in fact, I'm just going to label these 2 points. Negative 1 comma 4. And let's label it. And the other one was 3 comma 0, I believe. All right, we'll actually get rid of these. Those just help me find those points. Now what I'm going to do, I'm going to copy and paste this so we can draw on this a little bit. So give me 1 second while I do that. All right. You know, I'm going to do one more thing in Desmos just to make it a little bit easier for us to read it. Let's see. I think I can do it here. I don't want minor grid lines. Okay, that's fine. And we're actually going to zoom in so that we can see all of our grid. Okay, so I'm going to re-copy and paste this. And this will be easy for us to discuss. Okay, so here's how I think of average rate of change. Here's my 2 points that I'm trying to go between when x is equal to negative 1 and when x is equal to 3. And on average, I'm trying to figure out by how much does the y value go up or down every time the x value goes up by 1. What we're really doing is we are just, what if I connected, instead of going the long way around, dipping all the way down and coming back up in a U, what if I drew a straight line in between these 2 points? And I'll try to make it actually straight this time. What I'm really asking is, what would be the slope of that line if I took a more direct path? And if you find that slope, right, it would be, we'll say this is x1 and y1, and this is x2 and y2. So that would be 0 minus 4 divided by 3 minus -1. And you can see we basically get exactly what we had above, right? So that's going to be -4 divided by 4, which is -1. And we can also see, like if we did used one way that we sometimes think of slope that you might have heard before is slope is equal to the rise divided by the run. And if I'm on this line, I can see that every time to get from one point to the next point on this line, I go down 1 and over 1. So my rise over run would be -1 over 1, which is equal to -1. Or if you wanted to go from the original points, I go down 4 and I go over 4. Just a slightly different way of thinking about the same concept. Okay, so again, when you think of average rate of change, the way I would think about it is find those 2 points that are on the line. In this case, we were trying to go in between -1 and 3. So I found the points that are on our graph when x equals -1 and when x equals 3. Draw a straight line in between them and find the slope of that line. That's intuitively what we are doing. And otherwise, just make sure you use this formula, follow this example, and you should be able to find the average rate of change of any function. All right, hope you enjoyed the video, and we will see you in the next one.